Bismillahirrahmanirrahim. This is Pakistan International School Taif, grade 12, second year, and lecture number is 20. We are talking about chapter number 14, and the topic is transition pattern chromium. So yesterday, last lecture, we completed the conversion of the oxidation state of positive 3 of chromium. And we converted also chromium 3 to chromium 6 chromate yellow color. This was the yesterday. Now chromium 6 chemistry. Chromium 6. Chromium 6 chemistry. Oxidation number of chromium is 6. Written in the book, most important. If you had just produced the yellow chromate by using the above chemical reaction, hexahydroxo chromium negative 3 chromate negative 3. If you add hydrogen peroxide solution, upon heating, you will get the yellow chromate 6. He said if you had just produced yellow, means we prepare yellow by using this chemical reaction. By oxidizing chromium 3 using hydrogen peroxide, already I told you this. You can't convert them into dichromate, means this yellow chromate CrO4, you can't convert into dichromate. This is orange and this is yellow. He said that you can't convert cross. Reason that without taking precautions first. What precautions we have to measure for the conversion of chromate into dichromate? In the presence of acid, dichromate 6 ions react with any hydrogen peroxide. If you are going to convert into chromate into dichromate, so maybe this dichromate react with hydrogen peroxide. Hydrogen will be left in the solution because of some amount may be left in the solution after conversion of the hexahydroxochromate 3 to chromate. So which is left in the solution, some amount during the chemical reaction. So prevent this. When you are going to prevent this one, you have to heat the solution for some time. Means you have to heat the solution for some time to decompose hydrogen peroxide into water and oxygen before adding acid. Before adding acid, you have to heat this. Then the conversion of chromate into dichromate possible, because when the hydrogen peroxide is heated, the oxygen gas and hydrogen gas are going to be evolved, and these hydrogen gas and oxygen gas, they do not react with the chromate, and very easily this chromate ion change into dichromate, means yellow change into orange. This is the important, which is the most important. Now, from the chromate, this is an acid. It's called chromic acid. This chromate changes into chromic acid by using hydrogen. hydrogen. So if you replace this hydrogen, if we want to replace this hydrogen by metal ion, if we replace this hydrogen by metal ion, this metal may be sodium ion, may be potassium ion or other. These are the alkali metal ions. You will get salt. Salt is going to be formed, which is called sodium chromate or potassium chromate. Sodium chromate or potassium chromate, these salts are going to be formed by the displacement of hydrogen by metal ions. The salt of chromate are formed, and I told you these chromates are yellow. So these salts are brilliant yellow color. These are the yellow color salts and soluble in water. When acidify, the yellow color of solution changes into orange dichromate. So how we change chromate into dichromate? How we change yellow chromate into dichromate? So this is a chromate. So he said when you add acid, so hydrogen ions from the acid, so you will get the dichromate, and water is going to be formed. This is the conversion. This is the conversion. Reversible reaction. If you add the base, then this will be converted into chromate. But if you want to convert only dichromate, there is no reversibility. Then you have to put the this guy. So this is yellow, bright yellow, chrome yellow, and this is orange. So orange color of dichromate is going to be formed from the chromate. This is the conversion. Examples of important chromates I told you: potassium chromate, sodium chromate, lead chromate. We called it yellow chrome, which is used on the roads for the some barriers, some speed breakers. Or the pedestrians, they are across the road, so these are going to be used. Chrome. And there is another one, basic lead. Basic lead. So it is complex. It is a complex of two small complexes, which is lead hydroxide and lead chromate. This is called the basic lead chromate. Basic lead chromate is going to be formed here. Basic zinc chromate also there. These are the some compounds you can get from the earth. Naturally they are going to form also. So basic zinc, this is a zinc, ZN, and hydroxide, zinc hydroxide, and zinc chromate, zinc hydroxide, zinc chromate with one water molecule. So these are the basic lead chromate and basic zinc chromates. These are the chromates, and if you are talking about the dichromates you have ammonium dichromate, sodium dichromate, potassium dichromate, ammonium dichromate, sodium dichromate, potassium dichromate. So these are the dichromates: ammonium dichromate, sodium dichromate, and potassium dichromates. The salt of, and these are the salt of dichromic acid, H2Cr2O7. Hydrogen is replaced by ammonium ion, sodium ion, and potassium ion. So before I told you chromic acid, and this is called dichromic acid. So these salts are of the dichromic acid. In the presence of dilute sulfuric acid, these dichromate ions are a strong oxidizing agent and reduce chromium free. So how these dichromates, Cr2O7 positive 6 oxidation number, overall -2, aqueous is same addition of acid. If you are going to balance this 14 hydrogen ions and the gain of 6 electrons, so chromium positive 3 is going to be formed. So there are 2 chromium and there are 2 chromium ions plus 7 water molecules. So this is the reduction. The substance which is going to be reduced is called oxidizing agent. So potassium dichromate is a powerful oxidizing agent and it reduces positive 6 to positive 3. Now this is about the chromates and dichromates. Now reaction with zinc. Reaction with zinc. When potassium chromate reacts with zinc ions, is a potassium chromate and zinc ions in the presence of water. So you will get the zinc hydroxide and zinc chromate, zinc hydroxide, zinc chromate, 1 water molecule, and potassium ions are going to be formed. So when potassium chromate is added into a neutral solution of zinc salt, the basic zinc chromate, zinc hydroxide, zinc chromate is going to be changed into zinc hydroxide, zinc chromate, basic zinc chromate is going to be formed here. Reaction with acids. Reaction with acids. So potassium chromate reacts with sulfuric acid. Acidified solution of potassium chromate is oxidizing agent. So you will get potassium sulfate plus chromium sulfate and 5 moles of water, and this oxygen is called nascent, newly prepared, newly bored oxygen. oxygen atom is going to be formed, which is very reactive in nature, and it is going to be oxidized. That's why potassium chromate is a good oxidizing agent. You can see in your book page number 77. So chromium dichromate, orange color, oxidation number 6. You have to put the cotton not interoxygen gas. So intermediate is going to be formed with oxidation number 3. So hexa aqua chromium 3, inverted commas are only for the sake of simplicity, and it is going to be formed hexa aqua chromium 2. Color is blue. So this orange color and blue colors are going to form intermediate in between these two oxidation states. The intermediate oxidation state, positive 3 is also formed. So this is the one chemical reaction I told you. The ionic reactions are also here. These ionic reactions are dichromate, positive 6 oxidation state on the chromium, and this is same in the presence of acid, acidified potassium dichromate, sodium dichromate powder maybe, and you have to put a zinc metal which is 0 oxidation number. So this chromium positive 6 changes into chromium positive 3. So students, this positive 6 to positive 3, this is a reduction. So the substance which is reduces is called oxidizing agent. So 7 water molecules plus zinc ion. So zinc is going to be oxidized and chromium is going to be reduced. There is a oxidation and there is a reduction. Zinc is going to be oxidized and chromium is going to be reduced. So in the short, we can write here 2 chromium ions, positive 6, zinc metal changes into 2 chromium positive 3 and plus 3 zinc ions. So students, chromium 6 changes into chromium 3 and this is called reduction, and this is called oxidation. So this is a complete cell. We've done one is called oxidation half cell reaction, zinc to zinc 2, this is oxidation half cell reaction, and chromium 6 to chromium 3 is a reduction half cell reaction, and this reaction is called redox reaction. So redox reaction is going to be formed. So chromium 6 changes into chromium 3, and also in the presence of zinc, chromium positive 3 in presence of zinc. So this chromium 2 is going to be formed here. Yes. Again, there is again reduction of chromium and oxidation of the zinc. Now, dear students, there is another reaction you have. Using potassium dichromate as an oxidizing agent, like this. Potassium dichromate as an oxidizing agent, this example is given. Acidified potassium dichromate oxidizes zinc 0 0 to zinc positive 2. This is the example. And itself chromium positive 6, then this is chromium positive 3. So this also used in organic chemistry. We will also discuss how potassium dichromate acts as oxidizing agent in organic chemistry. So you will see that it oxidizes secondary alcohols to ketone, it oxidizes primary alcohols to aldehydes, it oxidizes primary alcohol to carboxylic acid. So one chemical reaction I am going to write here. So if you see the dichromate ions, Cr2O7 -2 plus 16 hydrogen ions, and there is ethanol, 3 moles of ethanol, CH3, CH2, OH. This is the ethanol, and it's going to be changed. Chromium is going to be reduced, C positive 3, it is going to be reduced, and plus you will get the aldehyde. This is aldehyde, acetaldehyde, and plus 7 molecule. So this is the aldehyde, ethanol. Aldehyde is going to be formed here. So in other chemical reaction, same potassium dichromate oxidizes also alcohol to carboxylic acid, CH3COOH. Page number 78, you can see the acid is going to be formed. So in the short chemical reaction, because of the nascent oxygen is going to be formed during this chemical reaction, this nascent oxygen is responsible for the oxidation of alcohol to aldehyde and oxidation of alcohol to carboxylic acid. These are the chemical reactions we use in the organic chemistry. So thank you very much. We stop here. Then we continue the using of potassium dichromate in oxidizing agent in titration. In titration, how potassium dichromate is used as an oxidizing agent. Thank you very much. We stop here.